All right, Algebra 1, notes 5.3, solving a system of linear inequalities. These are the last notes for the semester. So our learning target, I can graph and find the solution to a system of linear inequalities. So this whole unit is about systems. All a system means is that you've got two or more things going on. And when you have a system of linear inequalities, you're going to have two or more inequalities. Linear just means they're lines. So if you look here, there's a line. There's a line. Inequalities just means it's going to be shaded on one side or the other. So from this line, it's shaded below. And from this line, it's shaded to the right. So the solution to a system of inequalities is where the shaded area of each graph overlap. So let's look at example 1. Mrs. Wilson is buying curtains and artwork for her new home. One package of curtains costs $20 and one piece of art costs $40. She must spend less than $320. Mrs. Wilson knows she will be buying at least 4 packages of curtains. So we know that we have at least 4 windows that for sure need curtains. Maybe the other ones need curtains, maybe they don't. And then maybe she needs some art, maybe she doesn't. So here are our two inequalities. We use X to be the number of curtains and Y to be the pieces of artwork. So let me label that here. So X is curtains. Y is our art. So if we're going to spend $20 for each curtain, 20 is that X slope basically. So it's what goes out in front. And 40 goes with our artwork. Art was Y, so 40 is our slope on the Y. We're comparing it to 320. That was our budget, $320. You must spend less than 320. It means we can't spend exactly 320. We have to spend less than that. So there's no equal to. And then our other inequality comes from the next sentence. Mrs. Wilson knows that she will be buying at least 4 packages of curtains. So my curtains, my X, has to be greater than or equal to 4. At least. So this one right here. That is this inequality right here. It's kind of hard to see. If you look really closely, you can see that that is a dashed line. So I'm going to go over it with a dashed line. It's a dashed line because there's no equal to here. And then it is shaded on this side. I'm just going to add a little bit of color so we can see it a little better. Okay, and then our second inequality, X is greater than or equal to 4, is a solid line right here. And greater than is shaded this way. So we said that the part where there is overlap is this area right here. That is our solution area. So I'm going to go ahead and shade that a little darker so we can for sure tell. And then I am going to label it solution area. That means any point in this double shaded area is a solution to this situation. Any point in just the pink section or just the blue section or the section that didn't get shaded at all is not a solution. What about the lines? Points on a solid line are solutions. Points on a dashed line are not solutions. So let's see what it says down here. Could Mrs. Wilson purchase 5 packages of curtains and 3 pieces of artwork? That point's right there. So that's point 5, 3. Does that work? Yes. Why? Because it is in the double shade. So what we mean by double shade is it's in this section right here that is both shaded in pink and shaded in blue. So list and label one combination that would work. Give me something else that would work. Well, we could do this point right here. It's on a solid line, so it will work. It's 4 packages of curtains and 5 pieces of art. So that is the point 4, 5. Tell me one that would not work. Well, right here. What's that? 6, 7. The point 6, 7 would not work. We could not buy 6 curtains and 7 pieces of art. So that one, the graph was done for us. Here's another one where the graph is done for us. Sarah's pet store can only house a combined total of 16 cats and dogs. She always has at least twice as many cats as dogs. Write the system of inequalities and graph to show the possible number of cats and dogs in her store. All right, so I'm going to go back and label again. X is my number of cats. Y is my number of dogs. And then we have our 2 inequalities. C plus D is less than or equal to 16. When I add the cats and dogs, the combined total is going to be compared to 16. We can only have 16. That means, yes, we can have exactly 16, or it can be less than that. Then it also says she always has at least twice as many cats as dogs. So remember, twice means 2 times. So 2 times as many dogs. Or sorry, we have to do 2 times the number of dogs to get the number of cats. Alright, so if you are having problems figuring out which one of these 2 is which line here, you can always graph them. So we said X was the number of cats. So I'm just going to write a little X above the C. And Y was the number of dogs. So really, if I wanted to graph this and see what it looks like, I could graph X plus Y is less than or equal to 16. So let's review how to graph those kinds of things in here. So this starts out with F1 of X equals. Well, that's not how this equation starts, so I need to delete that. And the only one that doesn't start with the Y is option 6, relation. So I'm going to type it in, how it looks here, making sure you use the X and the Y. X plus Y is less than or equal to, so control equals brings up this menu. Find the less than or equal to 16. Well, that looks like the whole thing's shaded. Keep in mind this is scaled differently. So I'm going to zoom out. So menu, Windows zoom is option 4, and zoom out is option 4 again. Now if I look here, here's 0, 0. So right now, this is set to zoom on 0, 0. Well, I don't want to zoom there. I'm going to zoom somewhere over here. So that way, it looks a little more like this. Okay? So if you look at this line right here, it's this one. So, this equation is this line. It is a solid line. You can see that it's equal to, and it's shaded this way. So notice when I shade, I just draw lines. That's because if you try to do too much scribble scratch, when you try to figure out where the overlap is, sometimes that's hard. So then our other equation must be this one. Another solid line, and it's shaded this way. So where's the overlap? It's in this section right here. So, would Sarah's store ever have 8 cats and 8 dogs? So 5, 6, 7, 8. Go up 5, 6, 7, 8. Is this point right here a solution? It's on a solid line, but it's not on the solid line of the shaded area. So the only lines that actually count as being on the solution are the ones for the shaded area. So those two parts of the line I just drew over. This one is not a solution. So list one combination that would work and one that would not work. So pause the video and try this on your own. Did you get it? So one that would work would be anything in this double shaded area or on either of these solid lines. So I'm going to pick this one right here. The 0.93, which means 9 cats and 3 dogs. And a point that would not work, pick something right here. The 0.28. 28 would not work. You could not have 2 cats and 8 dogs. All right, so when we look at the next page, we've got a couple more of their graphs for us. Here's the great thing about this. It just asks, is it a solution? So the only thing we really got to figure out is where is it shaded. So this first line here, y is greater than x plus 2. See how that y-intercept is 2? I know that's got to be this line right here that has a y-intercept of 2. So I'm going to go over this. And then it's kind of hard to tell over here which side it's shaded on. But look at this. You can tell that it is shaded above. Here's the other clue. It's greater than. Greater than means shade above. So that one's shaded this way. Okay. So then our other one has a y-intercept of -3 right there. So it is this one. It is a solid line because it does have the equal to. And then it's really easy to tell right here. It is shaded this way. So where's the double shade? It is this section right here. There is a solid line on that part and a dashed line here. And all of this is in the shaded area. So is the point 1, 1 a solution? 1, 1 right here. No. List 2 possible solutions. So pick 2 things over here in the shaded area or on this part of your solid line. So I'll pick this one, 0, -10, and I'll pick another one. Sorry, that's not 0, -10, that's -10, 0. There we go, -10, 0. And I don't know, let's do this one. -2, +3. You can pick anything you want in that double shaded area or on this solid line, but not on the dashed line. All right, I want you to pause it and try example 4 right here on your own. Then hit play and see if you got it. All right, let's check. So the first one has a y-intercept of +2, so that must be this line right here. A solid line, and you can tell from here, this one is shaded this way. Okay, our other one has a y-intercept of -2. That must be this one here. It is not equal to, so it has a dashed line. And then if you look here, you can tell it is shaded this direction. So then our double shade, the part where it overlaps, is this section right there. Is the point 1, 1 a solution? 1, 1. Yes, because it is in the double shade. List 2 possible solutions. We'll pick any 2 points you want there. It looks like 0, 0 is a solution. Then it looks like, oh, I don't know, this one right here. 4, negative 3 is also a solution. Alright, so what about if it doesn't give you the graph? If it just gives you the equations, excuse me, the inequalities, and you have to graph them. So up here, they were both in slope-intercept form. They were ready for us to graph. So you can rearrange these, get the y by itself, so that you can graph them. Alright, so in order to get the y by itself, we got to get rid of this x. So this x is a positive x. The way I get rid of it is to subtract x. And whatever you do to one side, you got to do to the other. Okay, those cancel. Y is greater than, and then you could write it as 3 minus x, but slope-intercept form would be negative x plus 3. Okay, so I always start with my b. b equals, this one is a positive 3, so I'm going to start out at positive 3. And then my slope is what's out in front of the x. So it's this negative sign right here. That is a negative 1. But if I need it to be a fraction, negative 1 over 1. So from here, I rise negative 1, which means go down 1 and over positive 1. So we had a couple of points drawn, and then we're going to connect it with a ruler. Okay, so before I connect it, I'm going to check solid or dashed. Well, this one is going to be a dashed line because there is no equal to. Okay, and it is a greater than, which means shade up. So from my line, anywhere on the line, go straight up. That's the side you're shading on. So remember, I just draw the lines for my shading, so then I can tell where my overlap is a little easier. Okay, I'm still trying to solve for y. So this time it says minus x. The way that you get rid of minus x is to add x. And whatever you do to one side, gotta do to the other. So those cancel. I'm left with y is less than x minus 1. So my y-intercept is negative 1, right there. And my slope, what's out in front of the x, well, there's nothing there. Remember, there's always an imaginary 1 if there's nothing there. And we're going to make that a fraction over 1. So up 1 over 1, up 1 over 1, up 1 over 1. So I'm going to get 2 points. This one does not have an equal to, so it is a dashed line. And this one is less than, which means shade down. So I'm going to draw my dashed line through here. Shade down. So from anywhere on, shade down. That's this direction. And remember, your double shade is your solution area. So I'm going to go over it. It is a dashed line right here. I always shade off the graph because actually this plane goes on forever and ever. So we're saying anything that would be in this area here would work. So answer the questions. Is 4, 0 a solution? 4, 0 is right there. Yes, it is a solution. List 2 more possible solutions. So you can't list anything on either of these lines, but you can list anything in this area here. So the 0.95 works. And the point, we already did 9. Let's do right there. 7, negative 1. That one works too. So we have the same idea here on example 6. We're still trying to get the x by itself. Or sorry, the y by itself. So first we need to get rid of that x. It is a positive x, so I'm going to get rid of it by subtracting x from both sides. So those cancel. Negative 3y is greater than negative x minus 6. Okay, still trying to solve for this y right here. So the way that I get rid of that negative 3 is to divide. Dividing is like distributing. Do it through everything. Did you catch it? Woo, 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 woo. There's an alarm going off right now. Because what did we do right here? We divided by a negative. What happens with inequalities when you divide by a negative? Gotta flip the sign. So this goes from a greater than to a less than. So those cancel. Y is less than. Negative divided by negative is going to give me a positive. Remember there's a 1 out in front of that x. So that fraction right there is 1/3 x. Negative divided by negative is positive. 6 divided by 3 is 2. So to graph this, my y-intercept is positive 2. Got it. Slope is 1/3. Up 1 over 3. Rise 1, run 3. Okay. It is going to be a dashed line because there is no equal to. Less than means shade below. And solve the last one. 5x minus 3y is greater than 6. So let's solve for that y right there. It's a positive 5x. So the way that I get rid of a positive 5x is to subtract 5x from both sides. Negative 3y is greater than negative 5x plus 6. Got to get rid of that negative 3, so I'm going to divide by negative 3. Woo, woo, woo. Look what we did right here again. We divided by a negative. If we divide by negative, we got to flip the sign. So this greater than is going to become a less than. So y is less than. Pen's running out. Negative divided by negative is positive. Just going to leave it as 5 over 3. We don't want yucky decimals. Just leave it as a fraction. 5 over 3x. Positive divided by negative is negative. 6 over 3 is 2. So to graph this, I'm going to start out at my y-intercept, negative 2. Negative 2. I'm going to rise 5, run 3. 1, 2, 3, 4, 5. 1, 2, 3. 2, 3, 4, 5. 1, 2, 3. Can also go down 5. 1, 2, 3, 4, 5. Left 3. That'll also give me another point on the line. Solid or dashed, another dashed line because it doesn't have the equal to. Less than means shade below, so that's this way. Pen's running out on me. I'm going to highlight it. So where's the overlap? We've got this dashed line here. this dashed line here. And my overlap is this section right here. Is 1, 1 a solution? There's the point 1, 1. Is it a solution? Nope. It's not in the double shade. It's in the pink shaded area, but not the double shaded area. And it's close, but not quite. So let's 2 possible solutions. Any 2 things in here. So let's go with the point 10, 0. And 0, negative 10. We'll take 2 easy ones for that one. All right. So flip back to your quality question, page 10. Let's talk about something. Your quality question says, how many solutions are there to a system of inequalities? So last time we did a system of equations, and we talked about how they could never intersect, no solution. They could intersect one time and have one solution, or they could be the same line and have infinitely many solutions. So how many solutions does one of these have? How many points are in here? That's what your quality question's asking. So think about it. How many? So like, can I go through and put a point on each of these? Is that how many solutions there are? Remember how I always shade off the graph? That's because it actually keeps going. So this section would keep going forever and ever and ever. So there's actually infinitely many possible solutions to any kind of system of inequalities. So systems of inequalities, all we're doing is graphing them and checking for answers. Hardest part is probably this solving here. If you don't like this solving, you can always type it in your calculator. So let me show you how to type this one in your calculator, and we'll compare it to what we have down here. Home screen, new docs, don't save, add a calculator, sorry, add a graph. So we're going to graph this. X minus 3y is greater than negative 6. Don't want that, so I'm going to delete it. I'm going to click relation. Type it in exactly how the original problem looks. X minus 3y is greater than negative 6. You can see it's that line right there. It's shaded below. Okay, let's graph this one. So I'm going to hit tab to get relation 2 to come up. 5x minus 3y is greater than 6. So that's this line. Sorry, the colors are flipped. Should have done blue first, I suppose. But you can tell this double shaded area is where it's purple. Same here. The only thing that's hard is if you got to go from this to putting it on a graph. It's hard to tell where those lines go. Remember, you can always add a grid. So menu, and it's under view, which is option 2. 6 is grid. And I like the lined grid because it looks more like graph paper to me. So if this helps you put it on here, you can use that as well. All right.